It's been a while, but it's good to be back. Welcome to Decades. Today's topic is an overview of our universe's deep and recent history, and some context for our current reality and for the events of the Big Bang and early universe. This is the context for our cosmic history. The word cosmos in Greek means world, harmony, order, and we're going to find out what that means in these next topics and lectures. We're going to run down what we know from sources like the Smithsonian and Neil deGrasse Tyson. We'll talk about particles, energy, and such, and review everything at the end. By the way, if you don't like the fast or slow pace of the video, feel free to pause it at any time or simply put it at a different speed. So now, to begin, I'll say that my cosmic history info comes from 2017 to today from Stephen Hawking and Neil D. Tyson, as well as the book Universe, the Definitive Visual Guide by the Smithsonian, and a whole bunch of other information comes from the website Britannica, which is basically Wikipedia, a place with a lot of information. It's fancy, but you have to pay for it. I also use Western government research websites like nasa.gov to help clarify certain details as well, and sites like Smithsonian, National Geographic, and high-level universities for the same clarity. And I make sure that this info is correct in my books and Britannica as well. Anyway, that's where I get my information. It should be in the description, and it starts with a singularity. A point in space and time that was infinitely small, infinitely dense, with unlimited power and heat, and infinitely curved, even though it was only a single point. Stephen Hawking himself says, quote, "Space-time is smooth and nearly flat, so it breaks down at the Big Bang singularity where the curvature of space-time is infinite," end quote. Page 49 of A Brief History of Time. So the singularity was infinitely small, dense, hot, and curved. It was a superparticle of pure light, which is pure energy, where stuff that is largely impossible now was very, very common. 13.8 billion years ago, when our current reality started and what's called now the Big Bang. But if you want to be Greek about it, it might be called I Genesis του ουρανού, the sky's birth. It's Genesis in biblical terms. Anyway, about those 13.8 billion years, that's a ridiculously big number. It's even hard to understand for trained scientists. So let's explain it in easier to comprehend terms. 5 years is often perceived as a very long time. I, for instance, used to be a devout Christian 5 years ago. But after a lot of disillusionment with it, I've entered a more secular part of my life. I used to have a lot of optimism that my life could drastically and realistically improve if I just persevered long enough. A lot of people, notably young people, can change in significant ways in just 5 years. We can often become very different people. Elementary, primary school you would be different from middle school you, who would then be different from high school, college, 20s, 30s, etc. you. A lot can change in a somewhat short or long period of time. And side note, a lot of your body's cells are replaced on a regular basis. Fat and bones are replaced every 10-ish years. Your red blood cells are replaced every 4 months. Stomach and white blood cells are often replaced every few days. But your brain and the surface of your eyes and teeth last pretty much your whole life. So, in many ways, much of your body is replaced every 10 years. But this varies drastically depending on the cell. So, 5 years and 10 years are a long time. And a whole lifetime in the US of about 80 years means many seniors in the 2020s were born often during World War II or just in the 1940s. This is when the Cold War was started. Earlier, the Germans and Japanese were trying to dominate the world. Furthermore, much of the world was covered in oppressive European colonies. The world population was 2.5 billion or less as opposed to 8 billion-ish that we have now. The world was very different 80 years before now. Double those 80 years, and we're in the 1860s. The US Civil War was ongoing. Europe and places like Brazil, India, and China were dominated by kings and rulers who inherited their lands. Queen Victoria was ruler of England and its vast and powerful British Empire. China and Japan were undergoing humiliation and transformation with their emperors' governments and such. 1,000 years ago, we were in medieval times where Vikings were around. The year 1000, everyone was dying of disease like smallpox, and the Byzantine Romans were still a strong empire, like other entities across the world with, in general, very centralized governments and very powerful emperors, dukes, kings, or whatever, who no one questioned because peasants and landlords were on a pretty good level ground with each other. They often had great respect for each other. Peasants worked the land and generally kept like 85% of the food, the harvest they farmed in the year, and landlords protected the peasants from threats like Vikings, wild horse riders, foreign kings, or whoever. In and out of medieval Europe, we can see societies of equals in barbarian and governmental regions as well. Another 1,000 years, and it's when Jesus Christ was alive. The Romans, Persians, Chinese, Mayans, among others, dominated their corners of the world, and barbarian factions controlled very small territories individually, but many of these tribal bands collectively dominated many arid and jungle places, generally in the middle of nowhere, collectively holding most of Earth's lands. 10,000 BC, and humans were just beginning to adopt grains and grass harvesting on a more advanced scale, and no animals other than dogs were domesticated at this point. But a lot of this stuff is still being debated and analyzed by smart people. New archaeological finds are being made every month, every year, all that good stuff. 100,000 years ago, most, if not all, of the human population is still in Dunya Meriti, East Africa. 1 million years, and Homo erectus was still the dominant ape of the world, and ice sheets covered Chile and Tibet. 10 million, and about 50% of mammal families we know today didn't exist yet, only their weird-looking predecessors. The great-great-great etc. grandparents of more advanced animals, humans and such that appear later, the prehistoric prototypes, and many still weird and horrifying animals yet lived on the Earth. 100 million, and the Earth looked like this. The continents were much closer together, water was everywhere, jungles were at the poles, and dinosaurs still reigned supreme. 1 billion, and the Earth looked like this, and all individual life forms were just microscopic. 4.6-ish billion years ago, and the sun, the planets, all our solar system was in a very nascent stage of development. It was a lot of gas and dust, the ashes of likely several stars that exploded in violent supernovas, explosions, or ejections. The sun was compressing, but technically wasn't yet a star, and this was after the Milky Way itself gained much of its current mass by 10 billion years ago, which is when infinite other galaxies, or at least roughly 2 trillion galaxies in our observable world, were also spinning, evolving, and changing in multiple ways, with new planets, new events happening on the widest scale of the vast infinite universe. 13.8 billion years ago, and the universe was at a singular point, a zero-dimensional space, a singularity. So this brief history of everything gives you a giant scale of how old the universe is. 1,000 years is indeed a long time for us humans, but in the grand cosmic view, it's nothing compared to the true age of the world around us. And for this Big Bang in universe stuff, space-time is one thing, not two. There are 3 spatial dimensions, and 1 time dimension, or so Stephen Hawking and many professionals say. 3-dimensional beings can go through width, length, and height, but are mostly forced to move forward in time. They can rarely stay put or go back in time. These are 3-dimensional beings. So in this singularity, the normal laws of physics don't apply here. Gravity, the nuclear forces of atoms, and then electromagnetism. All of them were combined in what's called the superforce. So this singularity can collapse in on itself, and it was infinitely hot. So hot because of the infinite or just vast amounts of energy in said superpoint. Thus, in physics, whenever there is a singularity, the laws of physics will fundamentally change, and this is by definition of Einstein's general relativity, invented and agreed upon all the way back in the 1910s. And perhaps these particles of energy, these photons in the beginning, maybe were string particles. Strings in this context are very, very tiny bits that have one-dimensional length, but we will cover strings and the before and after of the Big Bang all next time. So the universe started as a singularity with unlimited power and such. It was a superparticle of photons of light. We've talked about how tremendously very, very old the universe is. Space-time was a very gurgling incurved thing. And yes, space-time for now will be talked about as one contiguous proverbial fabric. There are 3 space dimensions and 1 time dimension. Other additional dimensions are likely, but not yet confirmed. 3D beings mostly go forward in time. The natural forces were combined in the superforce, and thus in any singularity of this infinitely small size, Einstein and others pretty much knew that the laws of physics would change at these incredibly very small sizes. And as said, strings and more will be discussed next time. Take care.